Hi, this video will talk about Newton's law of gravitation. Well, let's start with something familiar. We know the weight of an object. It's basically a gravitational pull, right? The weight, it's the force, it's gravitational pull, and from the Earth. Now let's thinking about this. When we have two objects, mass 1 and mass 2, and Newton discovered that those two masses, they attract each other. So in other words, we will have M2 gonna attract M1, pull M1 closer, and M1 is gonna pull M2 closer, right? So this is those two forces, F1 and F2, they equal. So those forces are equal and they act at opposite direction. Opposite direction, opposite but equal. And this phenomena can be explained by this formula. This force F is going to be, I'm going to write down this F, the equal to F. F is going to be equal to mass 1 times mass 2, then the distance between those two objects is r, for example, divided by distance square, and then we're going to time this constant. This constant is called the universal gravitational constant. Okay, so G is universal gravitational constant. Since it's a constant, it's going to have its own value. It's 6.673 times 10 to 10 to negative 11 meter cube per kilogram per second square. Well, we don't need to remember this one. It's going to be available to you. Okay. So knowing that, that's going to be the formula capture Newton's law of gravitation. That means when there are two objects there, they're always going to be attraction. So can you imagine if you are sitting in front of this computer looking at the screen, and you and the screen is actually have some kind of force to pull each other closer. But why it's not close, right? Why it's not like dramatically closed up? Because this force is actually quite small. So it's very small and it doesn't really conquer that, friction. So in other words, so that's let's take a look at example then. Thinking about example 1. So we talk about random two objects. They do have attraction, but this attraction force is too small. But thinking about if we are no longer two random objects, it's you and the Earth. You are standing on Earth. Why the Earth is something no longer random? Because the Earth has so much mass, right? So then this mass here is going to be huge. Then that force correspondingly going to be huge. So that's caused our gravitational pull. That's our weight. So imagine this is our blue Earth. And this is us. I'm going to draw stick figures right here. This is us. And you are standing on the surface of Earth. This is mass 1. This is mass 2. And the distance between you and the Earth's center, that's your r. And that happened to be the radius of the Earth. Right? Then let's figure out that attraction, that force, how much that is equal to. So we're going to use this formula. F is equal to G. G is 6.673 times 10 to the negative 11. And then M1, that's going to be us. That's going to be you standing on Earth. And M2 is going to be the Earth. The Earth mass is a constant value, and that value is going to be 5.97 times 10 to power of 24 kilogram. It's huge, isn't it? So it's 5.97 times 10 to 24 kilogram. So that's mass 2, that's Earth. Then the distance between M1, which is you, and the Earth is the radius of the Earth. And that value is also a constant. That is 6378 times 10 to power of 3 meter. It's pretty long, right? 6378 times 10 to 3. And then that's squared up. That's our R. And if you go ahead, I encourage you to pause the video right now to go ahead, put all those constants together. So this value times this value and divided by the square. So tell me what you will get at the end. And I really do encourage you to try this because you need to only try one time. Once you have it, you are convinced. When you put all those numbers in, what do you get? Okay, pause the video. Okay, now I hope you had it to a number. And this is 9.8. That looks familiar, right? Then times M. Voila! That's how that 9.8 comes up. Our gravitational coefficient. We know it's 9.8, but why is 9.8? Here you understand the background knowledge behind the scene. Where is that coming from? So that force, that's gravitational pull from Earth to us. How much are we pulled by Earth? That attraction force, it's mass times g, mg. That's how our weight is derived. And all those are coming from gravitational pull. Okay, so in the next video, I will look at some example of the Newton's law of gravitation. All right, I'll see you on the next one. Bye now.